All right, we're in chapter 5 on accumulating change, limits of sums and the definite integral. This is section 5.8 on average value and average rate of change. So averaging is the balancing of extreme values. You're familiar with calculating test averages by adding all the grades together and then divided by the number of tests. Now these are called discrete data. And now the section we're starting here is going to introduce averaging in continuous situations or in situations where the discrete averaging is impractical, as you'll see here in the first example. So what we're doing is we having a person do some exercise over a 50-minute period. And in the first graph here, we're taking a reading every 10 minutes, okay? Or every 10 minutes. And so as you can see, it kind of makes a curve that's not so nice. It's not very nice. Now, if we cut that in half and average every 5 minutes, we get a curve that looks a little bit more like some kind of a smooth curve. This one's more like peaked and on both directions. And this one has more of a smooth shape. And if we actually model this and use regression analysis, we're going to come out with this function here. Okay, and so what we can do then is we can use that function. We can take the antiderivative of it and average or go from 0 to 50, and then that would be able to tell us, how many beats there are under that curve. So when we do that, it's going to look like the curve here and all the blue area here. So that's going to be 5,067 beats we find. Now, we went by, excuse me, 50 minutes. So if we divide that by 50 minutes, we're going to find that we get an average of 101 beats per minute. Okay. Now, if you look over here, this one here, we're going to get some kind of a different average. The first one is about 100.8. Then we do this one, it's about 100.7. And then based on our function doing it the way we did it, we get about 101 if we round it to the nearest whole minute. Okay. And so that's kind of what we're doing by averaging. Now, how does that work? Well, this is what it looks like in actual equation form. The average value of f from a to b is going to be the antiderivative from a to b of f of x dx divided by b minus a. Remember, we did 50 minus a. We just said divided by 50 because, we did it over 50 minutes. But really, we were subtracting off that zero start. And so that's how it worked. Okay, so that's going to be how we calculate our average value. So let's look at an example here. So global sea level over 3 centuries has been reconstructed by scientists as a function g of x, where x is the number of years since 1700, and the global sea level is indexed at 0 meters in the year 1932. Millimeters, sorry. So calculate the average sea level between 1700 and 2000, and then what is the global sea level expected to be in 2020? All right, well, if we're going to find the average sea level, we're going to have to take the antiderivative of g of x from 0 to 300, and then we have to take 300 minus 0, and that's what we see here. And if we'd actually plug that into our calculator, we can plug it in directly as it is, except, this is going to be in our y1. I usually is how I do it, and then be y1 dx, and divided by 300 minus 0, and we get about negative 75.55 millimeters is the average sea level from 1700 to 2000. All right, and so if we look at a picture of that, that's what it would look like here. So again, 1932, they said it was 0, and so our shape would look like this, and our average is right there at the negative 75.55. Now, this one says, okay, what's it expected to be in 2020? Well, we're going to plug in that value right here, 320, and figure out what it is. And if we plug it in, we get 184.39 millimeters. And then it says, write a sentence comparing this value to the value found in part A. Well, where is that value? Well, that's all the way up here. And how does that compare to this value here? Well, if we take 184.39 plus 75.55, that's because we have to add this distance plus this distance, that's going to give us about 259 point something, but it's about 260 millimeters higher than the 3-century average ending in 2000. So it's much higher than it was before, and so that's kind of a way we can use our average again. First, finding the global sea average, and then comparing it to some point in time to that 3-century average. All right, so let's stop there. We'll come back for more.